Today we're going to be discussing the effects of polarity on a solution. So we need to remember that water is polar, and that is what gives it the ability to be our universal solvent, because it can attract things that have full positive and negative charges, like that we see in ionic compounds, as well as partial positive and negative charges that we see in other polar compounds. And it does this by changing which direction it is facing in order to attract the particle of the opposite charge. So here we have a little Mickey Mouse style water molecule, and we have our partial negatives on oxygen and our partial positives on hydrogen. And we have them being attracted to the oppositely charged ions that are present in this solution. So we have our negative oxygen being attracted to our positive potassium, and our positive hydrogen being attracted to our negative chlorine. And whenever we see that we have both positive and negative charges, when we have our ionic compound that has dissolved, we have created something called an electrolyte. And an electrolyte is an ionic compound that has dissolved into water. And since an ionic compound has dissolved into water and we have those nice full positives, full negatives, we are able to actually conduct electricity. So an electrolyte can conduct electricity, whereas a non-electrolyte is a covalent compound who cannot conduct electricity. Now the difference mainly here is going to be the difference between ionics and covalents. Ionic compounds have those full positive, full negatives. Covalent compounds do not, and therefore they are bad at conducting electricity, and therefore they are non-conductive, and so they are a non-electrolyte. So what we're going to do now is we are going to be diagramming what a solution of sodium bromide would look like on a molecular level. We're going to zoom real far in and see what this would actually look like. Now what we need to do first is we need to determine if this is ionic or covalent, and if it is ionic, we need to identify which is the cation and which is the anion. The reason that I care so much about this is just because I need to know which way I'm orienting my Mickey Mouse head water molecules. Which part of the water molecule is going to be facing which ion, okay? So I need to determine if sodium is my cation or if my bromine is my cation and what their initial charges are. So sodium is going to be a metal. It's on the left-hand side of the periodic table. It's right here in the alkali metals. I see that it is in column 1, which means that it has 1 valence electron, which also means that it is going to give away that 1 valence electron. Giving a gift is a nice thing to do, so my sodium will be a positive 1 charge because it gave 1 thing away. Whereas my bromine is a nonmetal. It is in the right-hand side of this periodic table, and it is in column 7, meaning that it has 7 valence electrons. And since it has 7 valence electrons and it wants 8, it will steal 1. Stealing is bad, so it will have a negative 1 charge because it stole 1 thing. My cations are positive, which means that my sodium with its charge of +1 is going to be my cation, and my anion will be bromine because it has a negative charge and anions are negative. And next what I'm going to do is I'm going to go ahead and draw out my diagram, and I'm going to make sure that I am keeping the number of each ion correct according to their formula. So NaBr, I have 1 sodium for each bromine. It's a 1-to-1 relationship, so whenever I draw my solution, I need to make sure that I have a 1-to-1 relationship in that solution as well. So here you can see that I have my solution. You can also see that I decided to go with a little bit more of a picture style drawing rather than keep the compounds as Na and Br. And that's just because I thought that it would look nicer and it's a little bit cleaner in here. So I created a legend over here. I have bromine being a blue circle, I have sodium being a black hexagon, and I have water maintaining that little Mickey Mouse style. Okay, up here we can remember that our little ears for our Mickey Mouse are going to have a partial positive charge. So my partially positive part of the water molecule are going to be attracted to the oppositely charged bromine particle. So my positive part of my water is attracted to the negative part of the bromine. And so we have all of those kind of clumped around there, positive to negative attraction. And we also have a sodium ion here. And since sodium is positive, I have the negative part of my water molecule facing the positive part of the sodium ion.